You guys, long time no see. Let me know where you're from and if the video sound is alright, and let's get started coding. So today I will be coding some pretty cool shader, but with a new shader technology, with the TSL shader language, three.js shader language. So active theory website. Alright. Buenos noches to Tijuana and to all the other locations where you are and watching me. Alright, I gotta go get the chat and arrange the windows, stuff like that. And there's a delay, so you'll only see this like in a minute or something. Hello to Afghanistan too. Alright. Let's do it like this. First of all, I'm gonna create the folder. I'm gonna call this one active, because this is a stream dedicated to the active theory studio shader specifically. So I'm gonna copy stuff into the folder. Load Serbia. Also have two images. Just two images of shoes. Both happen to be Nike shoes. Alrighty. Alrighty, so I think the stream is going alright, right? Even though you haven't really said anything about it, but I guess it is good. Okay, and then active. Let's open the cursor. And that's also install the dependencies. And I'm gonna switch the screens right about now. So you see what I'm doing. So this is the website that I was going to like kind of re-implement part of the effects today. I mean, there's a lot of stuff going on here, obviously. And first of all, this one is dedicated to the technique on how to render 3D in a really high quality. So this is not really 3D object you see in here. Hello to Nigeria and hello to India. Oh, have some geography today. So this is not really a 3D object, and they have a dedicated article. You can find it in my latest tweets. But what I wanted to recreate, I really loved this transition effect. I think it's so awesome that I thought actually maybe we like tried to recreate it, but with the TSL. You know, we kind of created, I guess, similar things with GLSL already on this YouTube channel. But this time I wanna, it's like a challenge to me as well. I wanna create this with the TSL and see how, let's put a TSL to the test. Let's see how it works out for us. All right. So I guess this one is all right. I don't need this one. Let's arrange the windows. Almost right. Set the cursor. All right. I'll leave a bit of a chat here so we can read it. All right. So let's first start converting this one to the GPU, WebGPU rendering. Remove the stuff that I don't really need. GSub I don't really need. That's going to be WebGPU renderer, and this is going to be 3 WebGPU. And hello to Lviv. Nice to hear you guys. So we have the WebGPU renderer, and I have to convert the rest of the stuff to the WebGPU. Rest of my template. It's not really complicated, but yeah, just have to do this. There's no shader material with shaders. There is, though, node material. And there is no uniforms now. I don't need this stuff. I don't need lights too. Right, this seems good. Is it running? Right, something is running. This I don't get. Okay, I get. App GPU renderer is not a constructor. What? Right, and there's also render async. I was actually reading about the how to read notes properly because I wanted to create some animations with the music and with the correct tones and notes, things like that. And because I never studied music, I had to read about it. Yeah, so I just bookmarked. This is a pretty cool website, by the way. I'll just share it with you. I think it's pretty. I mean, it's kind of an art of the website. It's not just an article. It's also like interactive. Well, you can't hear it right now because I've connected, the streaming software, but you can interact with it. Anyway, let's get back to our. So we have a black thing. At least something is being rendered now, and what I want now is to create the basic shaders. So this is going to be this material color node equals fn, and then we'll start actually writing some TSL code. And this is the basic shader with the TSL that you could write, is actually interacting with the color node. This is going to be like a JavaScript function, which I would need to run immediately. And then in here, I'm just going to return for, say, red. I'll need to import all this stuff. Not free from the TSL. Do you need anything else? Was it just fan? Yeah, and vector 4. Right. So now we get the basic shader. And where do we go from that? First of all, I guess I would need to import the textures. Let's do it right away. So it's going to be one JPEG and texture to 2 JPEG. And then I'll load them and I'll try to use them on my mesh, right? First of all, I'm going to create the full screen quad. And hello to France. Full screen quad I'm creating. All right. So that texture 1 is going to be, yeah, basically this. And then I also have to have UV, and this thing will grow a lot. One of my kind of concerns with the TSL, I'd rather just copy paste one thing with everything and then just discard not used parts in the end. But we're gonna need to import every single function that we are using because this is not a real shader language. I mean, this is like a meta shader language, which will be compiled to the shaders. Well, you'd rather say thanks in the end. I might spoil it. Okay, anyway. So we have the, and it does work actually. It actually does work, right? Yeah. So what else could we do here? I think we can, for example, we can import the position local, position world, normal world, color. I don't think I need color and time though. But let's say we want to import we want to show the position world here, just for the, I don't know, lulz. Yeah, so we get the world position here, and we can also get the UVs here, just to test everything is working. UV is actually a function in TLSL, so you need to run it. So we have the UVs, everything is good to go. Now I can actually even sample the texture. So it's going to be const texture 1 is going to be texture, and then texture 1 in UV. Simple as that. And then I can just return the texture. And because we haven't imported texture yet, we can't actually sample textures. Yeah, I know. And cannot access texture 1 before, because why? Well, because it's, yeah, I have the same name for the variables. It's like final, I don't know, sample 1. Yeah, now we got the texture, all Gucci, and then let's use the other camera here. So I'm gonna use the orthographic camera instead of the perspective camera. So now I'm actually having a full screen quad always, like regardless of how I scale it, I will have it at full screen. But then Also have this aspect ratio for the camera. I don't really need. I need to stretch. Now, there's an easy fix for this stretching. So I'll just do where I go. I think I also rather, maybe not, maybe I rather not. I'll do a lot of space here just so I know where I need to put all the code. And then const u aspect equals uniform back to 1, and then this width divided by this height. And then I need to scale UVs obviously to get to the correct aspect ratio of my texture, because my textures are squarish and all I need is to actually multiply by the screen UVs. And this I'd actually create a scale UV function which will be scaling texture for me, which will be useful later on. So scale UV is going to be a function, yeah, like that, which takes UV as a variable and yeah, and scale. And then I can't actually multiply it right away. So I do something like this UA. Also, don't remember if we really mutate variables or not with this. So I'd rather do it to var, which converts it to like another variable. So we don't really mutate the original variable. So then I'll need to subtract center, and then I'll need to multiply it with scale and then add the center back again. This seems right, except that the uniform is not imported, yeah. And now the vec2 is not defined. Okay, I need all the vec. Let's also do the render async function. All right, so far so good. So let's scale the texture. Where is it? Here. So I'll just create corrected UVs or something. Yeah, I guess just like that. Correct UV is going to be scale UV. I don't know, where did it take this U aspect? Actually. And then I'll need to use this correct UVs. And all right, something already broke down. And why is that? Because it's not actually U. Okay, it's scaled UVs. Let's just output scaled UVs for a moment. Is it sampling that's breaking down, or is it? Okay, this is actually a scale UV function that is broken down. So UA aspect, which is a typo, I'd better call it like this right away. But then scale UV takes the UV and the function, and then it should return me everything corrected. This seems right. Maybe it's the way that I'm using the uniforms. Is it? Right. What does it say to me? No matching constructor for should it be just the scale UV? Yes, I don't need the array function here, right? It's just two variables that I'm using there. And why is it not working now? So I'm using UV and scale. Okay, let's just return UV. Okay, UV to var. some point there is a like error here. So we're normalizing the UVs, then we're multiplying it with scale. And then we're just adding back the center. So this seems right. Whatever got wrong, I don't know. Why did I have that mistake anyway? Seems like I just copied the top line and it just worked. Anyway, so let's try to sample now. Okay, this might be like the other way around. Yeah, so now we got the like the full screen quad. It's not complicated thing, but you know, sometimes it could be a little fiddly. Yeah, thanks. Yeah, it was two variables. Yeah. It was something else too. I don't know why. It seems like I just retyped. Right. Thank you, Mojojojo. Yeah, there was just not return function. I just assumed that it would return anything that I would type inside those braces. Yeah. And then why would I type it when I tried to retype that line? I actually added return for some reason. I didn't even think about it. Okay. Anyway, so we have the scale UV function. We have the full screen quad now with the TSL shadow language. Now what next should I do? So let's just see that it's working with both textures and it's fine. So it's basically, I didn't do the resize function on the browser resize, but when I just resize the browser, you can see that it's stretching the background. So it's working properly. Anyway, so now what I need to do next, I need to actually come up with some UVs that are hexagonal. So for this, I would need to re-implement the hexagonal grid here. I think there are a couple of ways to do this. This one is a bit angled, like inclined, I guess. But I do the straight one first, and then in the end we can incline it if you want. First of all, I'll need to build the hexagonal grid. And those grids build like hexagonal shader toy, hexagonal. You could go to any of those shader toys. There's already a set of functions, and they usually require two functions. One function basically gets me a sine distance field of the hexagon, right? So it's three-way symmetry thing. And let's call it the hex distance, and let's create another function, hex distance field, which is going to be and which takes just the UV, I guess. I don't need anything else. And on the UV, yeah, I need this like square root of 3 divided by 2, which is this is the square root of 3 divided by 2, which you need because all the angles are like 60 or 30 degrees, and you need this value to create this symmetry. And now I have to translate like this function. So first of all, I'm gonna do const p, which is gonna be absolute value. I need the apps now of my UVs, right? Whatever are my UVs, I'll need the absolute value of them. And then I can immediately return something like what? Like a maximum, and that's going to be a dot product of this p and has divided by half, and the s is actually this coefficient. And for my function, I think it's going to be the same. Yeah, as x, let's call it s2, s multiplied by 0.5. And the other part is have to be the px. All right. This seems complicated, but right. So p and s multiplied by 0.5, and then the px. and there's a px or y, I guess, depending on the orientation of the hexagonal and this particular shader. So p uv to var absolute seems right. So let's try to test this one. So we have this, and then x distance, and then uv sub 0.5, and then something like this. Yeah, you have to import max now. Okay, let's, yeah, max and dot product as well. Yeah, it seems correct, right? So this seems like a hexagon to me. Then I'll need to create hexagonal coordinates, which is like a bit more complicated part, because I obviously need a tiled set of these hexagons, because it's not fun to just have one single hexagon in the center. Well, I remember while I'm at it, I also need this smooth step. I would need the step. What else? I probably would need the sine, this stream at some point, maybe cosine. Yeah, well, these are already in there, right? I don't actually need to do this. Do I need something else? Yes, that's it for now. Anyway, let's continue. So it's a bit, it requires, I think it requires more concentration and focus with writing these shaders, because with GLSL you can just throw instructions line by line, and here you need to like connect each node to the next one. But then there's benefit to this. Yeah, okay, I'll just share the URL of what I'm trying to recreate here. Anyway, let's get back to it. What I wanted to do, I wanted to tile my x coordinates. I already have this function. It's a bit, I mean, if we look at it, like, let's look at how these functions usually look like. There's a bunch of dot products. Yes, it's this kind of math, and I'm not really in the mood to like explain all of these things. So I'd rather write it like line by line how this works, and then pray that it will work from the first try. So it is also a bit different, like depending on what kind of like approach you use for creating hexagonal grid. You could also, I guess, you could also technically use a sign distance field texture with hexagons. But then you wouldn't have as much of dynamics and flexibility with that. So for this one that I will be creating, I will also need a function which rounds the values, and this function, what it would do, it will just floor, this is what I need, floor, and then s at 0.5. This is what it would do. So for this I will need floor as well. I think there are some streams where people create like line by line how you build these distance fields. What I need now is a set of coordinates which will tile the UVs for me in a way that I can use hexagonal grids. So hex coordinates and all right, hex coordinates. So first of all, I'll need this S again. Then I'll need a bunch of calculations. So first of all, the hex center will be the S round function applied to 4-dimensional thing. And this is a really, yeah, UV to var. And then in this one, I will subtract 0.5 and 1 from this one. And then I'll need to divide all of this with this coefficient, not subtract, but divide with s, y, x, y. This seems right to me, although it's hard to... Okay, UA to var, subtract 0.5 and 1 is basically what you see in here. And then divide by this. And then we add this, and then we floor. And this is what I create in the sRound function, which I have right here. And then the hex center I have, and then I'll need to create like the offset for them. And the offset is going to be... And this is going to be UV sub x center xy multiplied by s. And then the second one is going to be same, but yeah, zw. But I will also need to add 0.5 to this zw before multiplied by s. 2 0.5 and then multiplied by s. Guess not like this, like this. So the result should be multiplied by s. Now I have this offset and I have this hex center, and these are these variables, and these I would need to take a lot of dot products and compare them now. So this is a bit just a method I need to write down. Okay, so dot one is going to be dot offset xy and offset y. It's basically the distance. I think it could have been done with the distance. And then const dot two is going to be offset zw, and then I also need to have the two set of coordinates in the end. The final one is going to be offset xy and then hex center xy, and the final two zw. Right. And then I can actually try to return for the first time something to just see something. Let's return final one and let's see how it works out for us. There is definitely some missing braces somewhere. Okay, now it works. So what I need to do first, I'll need to multiply my UVs with something. So const hex UV going to be correct UV multiplied, let's say, by 20. And then then I can apply hex coordinates to this one. So I can actually, I guess, should be ready to do this, right? Am I? Coordinates from hex UV, okay. Const hex coordinates. And then I can try to output this one. Yeah, because I have the same name for the function and the variable. Escorts. Like, this is the most tricky part of this stream, to just make it right. So which one is... No, where is the error here? So hex coordinates is actually returning me something 4-dimensional, and this is why I have this error probably. Let's say I'm going to take xy here. EW. It's all black. What the hell? And maybe final two. Maybe at least one of them is working. What the hell? It seemed so right when I wrote it down. Okay, so hex center xy multiplied by s. Maybe I'll just take the one that I prepared beforehand, but just wanted to write it down. Probably some math mistake somewhere in these hex coordinates. But it's damn hard to see one with the TSL. All right, so hex center seems right. So the offset seems right as well. Sub hex center xy multiplied by s. Ah, yeah. What the hell, yeah, guys. Thank you. It actually working properly. It's just too many hexes. Thank you. So, and if we do the ZW, we'd see something like this. So basically what it does, the XY is the UVs inside each like hexagon, and the ZW is like the ID, like the coordinate system, like 1, 1, 2, 2, 3, 3, like the number of the hexagon. And we need both of those, and yeah, let's just see that both of them are working fine. So the XY, and you could just see the change. If I change final 2 with final 1, it's a bit offset, and that's why we need these two grids. So now I need to compare both of these variables, and depending on the Menta, Mr. Hillips. And then depending on which value is bigger, I'll need to pick the set of the coordinates. So I'll do the diff then. Const diff is going to be .1 sub .2. And then final is going to be the mix, I guess. The mix, final 1, final 2, and the diff is just 0. Comparing the diff, which one is bigger, right? And the mix, I haven't imported the mix. Well, this is starting to look like something. Like maybe I'll just... Yeah, oh my god. I think we got it, yeah. So this is the set of formulas that you need to go to achieve. So now we are outputting the UVs inside each of them. Now if I do the ZW, you'll see that we are actually, it's like the big numbers. So this one, for example, I can just, let's say, divide it by 10. Then you'd see the set of the rest of the like the hexagons here. Yay. Oh my gosh. Now, the first thing I would rather do also, I want to distort my coordinate system. So I have the corrected UVs. Right, so this is working fine. I'm getting the hexagonal coordinates. And from my UVs, I can also sample textures, which we need later on. But what I wanted to do, I also wanted to have the corrected UVs, and I wanted to do the distorted UVs, just to distort UVs a little bit. And for this, I'll scale them again. I'll scale the core UVs, and in here, it's gonna be, okay, vec 2 and then float 1, so scaling it bigger. And to this one, I'll add the length of the distance from the center. So this is going to be length. And then what? UV minus 0.5, like the center. All right, let's just pray there's no error. Okay, float is not imported, and then length. I need float and length. All right. Yeah, seems to be working now. And if I now use these distorted UVs instead of the hex UVs in here, we get the distorted set of hexagons now, right? So I can actually sub 0.5, I can multiply this with, let's say, 0.5 to make it not as pronounced, but I guess for now it's fine to have it like this much distorted grid, right? It's basically what the barrel distortion looks like. It's how you implement barrel distortion in the fragment shader, which is also pretty cool, right? Already looks cool. So now the next thing. Now I'm actually putting now these set of coordinates divided by 10, which doesn't make any sense. It's just for the debug purposes. So the next thing I want to do, I want to actually use this information somehow to create borders of my hexagons and also some distortions based on this hexagonal field. Right. So, I can also now use these UVs to create the hex distance. So I'll just do the, have the coordinates now, right? The hex coords, and now I can do the hex dist, which is not the same as the name of the function. It was distance. Okay, so this one's going to be hex dist. I'm going to use it on the hex coords. And if I output this one now, this has got to be a float number now, so it's not a multi-dimensional thing. Then I get this, which is the distance field, the distance from each point to the closest border of the hexagon. So if I add something small here, I'll need to do this. It will just, oh, okay, yeah, I can. You can't just type plus. Yeah, I know. Yes, add something, and now I can use this value with the smooth step to create some borders. So let's first create the border. So the border is going to be a smooth step, 0.5, 0.5 plus what? Plus something small. And then, yeah, basically hex dist. Is this what I need? Is everything that I need to create the border? I guess so. And then let's use this border. Yeah, and we got it, right? So there's one thing that bothers me actually with this smooth step. If we just do this subtraction, you'll immediately get the error, and that's because apparently from what I see, like in GLSL you can use smooth step in two directions. Like this value could be less than the second one, or could be greater than the second one. But in TSL, at least for now, you have to like preserve the one is greater than the other. You can't just do it the other way. And with this one, you can actually, I think with this value, we would be able to, this is like a pixel value, more like a smoothing value of our border, and this is what would be the thickness of the border. So if I do like something like this, we get much thicker border. All right, we got it. So we got the border. Now I'll have to also create some kind of, I'll just call it y variable for the distortion. This one is basically taken from the original shader, and that's why I'm just gonna write. I also need the power function. Power function. So we're getting closer to the cool things. You just need to do a lot of basic things, and they take a lot of time. But then, with a couple of steps, you'll get really cool things. So this was raised to the power of 10, I believe. So it does some really strong, like smoothing, really fast going to 0. And then what's going to be the value here? I think it was maximum between 0 and subhex dist. Yeah, I'm missing something here. Right, everything seems black. I think it's also got to be 1 minus. I'm not mistaken. So it's maximum between 0 and 0.5 minus hex dist. To the power of 10. And this has got to be a 1 minus. Also need to import 1 minus. Yeah, so we're getting kind of a bloomy thing, I would say. And that's because we are just raising it to the really big power. So if I just make the power less than that, like not 10, but let's say 1, I'm gonna get something like this. Like there is a black spot in there in the center, but the more you raise, let's take 100. And 100, you're gonna get actually this kind of a smooth border, but I think it's not worth the computation power. So we need this to achieve like the distortion effects inside each of the hexagons. Right. So the most difficult part I actually find with TSL is like finding the right spot to write, because most of the functions are pretty long, like most of the lines with the code are pretty long, and you have to like be really focused and in the context, like where you are now, like what is it? Is this a POW or is this some other function? I don't know. I don't know how to solve this problem. In GLSL, it just solved basically by multi-line, a lot of lines of simple code. But here, this seems already like a short amount of code semantically, but in TSL it takes some space. Anyway, so we have almost all the things that I need. I also need the random function. So that was, let's say it's x, y, and let's call this one z then. This is going to be the random function. And for this one, I'll take the, how do you call it? A mix noise float, right? I have to import this one. Mix noise float, and then also remap. Yeah. Yeah, I guess that design might solve this one, like chaining this every single line. But then there's just not too many operations here, to be honest. But I needed to wrap 0.5 with float. And at least this one saved a little space, because I would need float 1 and then subtract something. This basically does 1 minus all the previous value. Yeah. All right, so a mix float noise. And for this mx float noise, I would use the ZW value of my coordinates, because it will be the same inside each hexagon. So x coords ZW. Do I need to multiply it? I'm not sure actually. And then let's output this Z value. Just the Z value, and then mix float noise. What should I do here? Maybe the absolute value. Maybe it's already working. Let's see. Mix float noise. It's a mixed noise float, I think. Absolute. Yeah. So it's basically a noise function which I can apply. Actually looks pretty cool on hexagons, right? When you apply some noise function. So what I need is just some random value for each of the hexagons, because I will use it to distort the textures later on. And it's nice that we have those already like in TSL, so we don't need to write specific functions for that. We already have the noise function. We also have a remap function, which is really useful because it just use it a lot, and you copy paste these map functions a lot. So the next thing is to actually get into the transitions itself. So first of all, I'm gonna create the variable offset, which is going to be the amount of the of my like transition, the longest part of my smooth transition. You're just gonna bear with me. I'm gonna see what it is. Let's say it's 0.2. I don't remember the exact value. Maybe it's smaller for the original website. Anyway, I also need like the bounce transition function, which will be useful, which will be smooth step in 0 and 0.5. It's going to be something going to the from 0 to 1 and back to 0. And for this, I just can take absolute value of the U transition. And now I need to actually implement the transition uniform. So const U transition is going to be uniform float 0, and then this not like this. So now I can enable settings, and now I can do this transition value val. Smooth step. Yeah. And here is going to be U transition minus 0.5 absolute value. Yeah, absolute I have U transition sub 0.5. So this centers and makes a symmetry and centers on the 0.5. And this should smooth step. Right, now maybe I'll just output the let's do something like this. Bounce transition. And also do one minus. So it's black, then when transition is in the center, it's 1, which is white, and then it gets back to 0. So just basically a sine. I think I could have used a sine curve from the pi multiplied with U transition. You would get the same value. I think in the other streams I used this. Right. Next transition functions that I need to use here to achieve this effect. I'll need like the curtain thing. So for this, I'll create the variable called blend cut, which is the same that I used, I think. And then I'll need to do the smooth step magic with these offsets. So with this, for the smooth step, I will need, I will make it vertical. So I'll need the UVY as the original, and then UVY with the offset. UVY, and then the add offset. All right. Or maybe subtract offset. I think it was like subtract and then add offset. So it's like a double offset range here. And then in the end, in here, I'll just use the U transition. And let's see what this blend cut does for us. Yeah, basically this. And I will also need to remap this U transition, remap U transition based on this offset, just so this cut is outside of the screen. I think it's going to be just the 0, 1, and then offset. Okay, offset multiplied by -1, like minus offset, and then plot 1 at offset. All right, so this is how you do these cutting functions. But what I could also do here immediately, because I already have the z function, I could add to this to my transition. I could actually add the z, but multiply it with something small. Z multiplied with something like. Now we're getting something like this. And I could also multiply this with the bounce transition, so it doesn't start with those visible. And then in the end, they're hidden, right? So this is now like a perfect transition, and we are getting something now. All right. So these are all like preparations for the actual thing. And what else do I need to do? I'd also create the function that they called merge, which is where like both textures will be basically merged. Let's also create sample 1, sample 2. And I can already do something like this, like const final, it's going to be mixed sample 1, sample 2, and the blank cut. What? Yeah. So it kind of makes this transition, and I intentionally picked the textures with different colors, so you could see how the one of the textures is actually like still some of the hexagonal pixels are still red, but this is still not the final thing that we want to do. So the merge one will be the smooth. It's just like the border of the transition. 0.5, and then I'll just do the absolute of the blend, cut, minus 0.5, and all of this 1 minus. Let's see. So the merge is actually just the something in between. It's like, it's just a running thing, like a cursor that runs through the center. And this I need to apply some specific distortions to my textures while we actually do it. And also to show the borders, because if we also multiply the borders, and we can actually try to do this. No, maybe it's going to be the last one. So first of all, now we need to sample the textures correctly so they are distorted in a nice way, because we still haven't used the y variable, which is the most important and the coolest one, which is the signed distant field of each of the hexagons. So now I'll need to use my UVs. So I have the UV. Which texture to use here? Right, so texture UV. Now I need to create two set of UVs for each of my textures and merge that together. So texture UV is going to be the distorted UV, and I have the corrected UV, right? Do I want to use a distorted UVs for this one? Yes, I guess so. I guess we can use some distortions on the textures. Anyway, so this UV, and then we'll add something to this dist UVs. So I'll add the actual distortion here, which is going to be the Y multiplied by now this comes a little complicated part. So I want to just add something dependent on this Y variable. And what this could be? Like some sine function from time, probably, and also need the time here. View transition, view time. Yeah, now I have the U time uniform, which I can use here to make some distortions based on time. So in here, what's gonna be? It's gonna be the sine UV Y part. Maybe multiplied by 5 and subtract the U time. I don't want to multiply time by anything. And then this is what I'm adding to this is what I'm multiplying my Y. And I could also multiply this with Y. So it only applies with merge. So it only applies to this center part. So this could be the merge and then multiply it with something, I don't know. I think it was this. So now we have texture UVs. Let's see what's gonna happen. And I want also to output not the merge, but the final now. I could see this nice distortion happening right in the middle where the textures are connected. I think it's better to use not the distorted UVs, but the correct UVs. And I could see this like distortions happening in, I think the time and the sign is maybe this. So it's not as obvious. And maybe also the time should be a little bit slower, right? Now you see, this effect actually consists from a lot of minor details, which when you combine them together, it just gets you a really cool effect. This is why, like, each single one of them might not look that cool maybe, but then in the end, it actually looks pretty cool. Okay, so what's next? So this is the correct UVs, but then we can also distort the UVs dependent on the other variables. So we have the merge, we have the cut, we have the blend cut, and I want to have the specific cut between two textures, because for now I'm using this like gradient function. I have the merge, the blend cut, and I also want the cut. And the cut will be the step function between, like, let's say UV Y. So basically it's a vertical curtain, which is dependent on the U transition, bounds transition, and the randomness. I need to add the randomness here, like based on Z. So it's going to be UVY and then U transition, which I will be adding some stuff to. What else? What should I add here? It's like, first of all, I need this Y. I also need to add this Z to Y. I also want to multiply this with something small, yeah. And I also want to multiply with bounds transition, so it's 0 in the start and in the end. Like now it's about finding which is the correct place to multiply it with the bounds. I think I don't want to multiply the whole transition, it's got to be here. Yeah. Right, so we have the cut function. Now let's implement cut function as the actual mixing function. It's completely different effect, right? You could see that we're actually moving through them. And then, like, when we get to the end, it's actually flat. Now you can, of course, we can change like this. It should, maybe it should only start flat and then immediately go into the like hexagons. Because for now, we have the distortions here and we have the hexagons. Maybe we might work on the easings and stuff like that. There's a lot of minor details and magic numbers. All right, so this is the cut function, which we actually will be using, I guess, for the in the end. So maybe also, I don't know, make it bigger. Like a little bit bigger distortions and a little bit more pronounced hexagons. It's already like, if we just add the border, I think it will just connect all the effects. But we also need to add a couple of distortions here too, just the minor ones, and we will be good to go. So I have the texture UV, which I'm using for both of them, but then I'm gonna create different UVs for from and to textures. So it's gonna be const from UV is going to be texture UV to var, and the same goes to the 2UV. And then for both of them, I'll add different distortions. So from UV, I'm just gonna scale it. Oh, I think the idea was to scale it depending on the depending on what? Depending on these distortions that I have inside of each cell. So we're gonna distort the texture by scaling it depending on the Z values, right? So it's gonna be from UV. Okay, let's just try to write this down. So it's gonna be from UV. And then how I scale it actually, right? So it's gonna be this, and then plot 1 again. So only making it bigger, like scaling it into the sides. And then we gotta add something to this one. And that something should be dependent on the U transition and the other stuff. So let's do it by adding z, multiplied by something, also multiplied by, let's say, merge, and add u transition. See what's going to happen, and then let's do the same for the other one, except in one of the cases I want to use I think not the merge but the blend cut, and let's call this one 2uv, and then let's call this one from uv and 2uv. All right, let's see what's going to happen now. Well, not much is happening, to be honest. I don't know why. Maybe I'll assign from UVs to both of them first to see what's happening here. Yeah, I think I can see this new distortion like happening in here inside each of them. But because the background is similar, okay, maybe let's use 2UV on both of them. Well, it's kind of the effect, except maybe some minor thing is missing here. I'm not sure why. Okay, let's add the border. Maybe the border will fix it. So, color blend will be what? I want my merge. I want it multiplied by border. And I want it also to multiply it with some like smooth stepping of my transition, right? At the bounce transition probably. Okay, let's output this one. Yeah, this is what I like wanted. I wanted this running border from the bottom to the top. Now I can just add this. Probably I can do after I have the final. Do the final, add a sign, and add some just color. It's gonna be vec4, something yellowish, and multiplied by color blend. I think I'll also make it brighter or something. Just multiply it a little more. This should add the border to the screen. It actually does add the border. You could see it here. I guess we gotta play with it, or maybe it's actually kind of cool. It actually does what it. Maybe this is the effect actually. There's some numbers which could be done though nicer, like the easings on transition, and also 2UV from UV. Maybe this one should be 2var. It don't seem to be scaling much in here. I think maybe the U transition should be 2UV like 2. This is actually should have been the scale. I'm not really scaling anything here, so I have to do the scale UV. Yeah. So now you could see why adding the like the transition actually scales. Yeah, I forgot to add the scale UV there, and that's why it didn't really change anything. And now it does distort things, except one of them needs to be, now both of them are actually using 2UVs, right? So I have to use one of them as using the from UV. You can see this nice effect, like where like each of the hexagons have the different UV offset in here. So I think maybe I just messed up the 2UV and the from UV. And also like this scaling, it shouldn't really happen. Like maybe I'll just remove the transition. Maybe it just should be a real slight zoom effect. Yeah, now you could see like this zoom, like when I'm moving the, like inside each of the, you see the texture is actually zooming and moving to different directions because we're using the random values from the sign, which could be negative. So some of the pixels are scaling upwards and some of like zooming out and some of them are zooming in. And that's why you get this like different, like it's especially nice to see it in this spot, right? So it's moving to different directions. Some of them are scaling really fast down and some really fast up. And then there's this golden border on top of this. I think this is the effect, right? Because you could add it's 100%. There's a lot more details to it. Like it has the inclination, and basically the inclination you would implement in these blend cut things. Like you would need not just the UVY, but you would need some rotated UV or UVY plus a little bit of the UVX, and then you'll get the rotation. But I think the most important thing I actually nailed it. So it gets this distortion. Pretty cool. What do you think, guys? I think it's pretty awesome. And the best thing about it is actually it is a lot of simple things combined. And I'm not talking about adding and multiplying things because that's complicated. I'm talking about the real like distortions which are being applied. So there's a distortion for the distance field for the each hexagon. There's a border added. There's also a function that mixes two textures, which is also using the hexagonal distance field. So there's like a couple of simple things combined together, and it is so awesome. Pretty cool texture transition, if you ask me. Phew. Yeah, I guess you could also use the time node, but for some reason I kind of still love to have this full control over what I'm using there and what's the speed of that time, so I can regulate it later on myself. I don't know. I guess I'll need to switch to their global functions that we already have in there. But I think I would call this one a success. This is a pretty cool one. And all the credits goes to the Active Theory developers because, well, basically all the websites that they do are bangers. And if you're like advanced in three.js, I recommend you really to check out the technique they use to render these, because this is not 3D object, and you could see it like here on the edge. If I move mouse slightly, you could see the edge appearing. So this is actually a sprite sheet, but like advanced sprite sheet. That's why it looks so smooth. But here you can't really see the transition between sprites, like on the watch itself, right? Only on the edges, like here, I could see this artifact. But here, it's just so damn smooth. It's like almost like a real 3D model. This is so damn cool. This is a really cool technique. Like one of the super clever things that I've learned in recent years, because really cool. All right, guys. So I'll be finishing the stream. Thank you for everybody for coming to this stream. I hope I will manage to stream last time of this year as well. I will share the code that I wrote today on the Patreon, so you could dig into these TSL functions. There's a lot of code that we wrote, and it's challenging for me, to be honest, myself, because I'm still trying to learn all of this stuff, making a lot of mistakes, but I hope you learned something new yourself today. So you have to go multiply things, add things, and then hope for the best. So my recommendation would be to, again, if you love somebody, don't forget to tell them that you actually love them, because life is short and you never know when it will end. So say some kind words this week to the people that you actually love. And I hope you liked the stream. And if you did, just put some comment or some on like, because this is what drives me, because basically this is all for free that I'm doing. And yeah. And yeah, Slava Ukraini, and have a great week. And hopefully see you this year after the Christmas. Have a happy holidays, everyone. Right. It's Christmas in 2 days, right? Have a happy holidays, everyone. See ya.